Yet another practical application we want to talk about actually includes defeating traffic analysis. So you might want to ask yourself, why would I want to defeat traffic analysis? I want to be able to analyze traffic, of course. Well, you have to understand, hackers also use traffic analysis. They also sniff, capture, and analyze network traffic using the same tools we do. But they have different goals. They want to grab different information than we do. They don't want to troubleshoot our network for us, or they don't want to stop attacks. What they want is to sniff usernames and passwords and get those if those are sent across the network in clear text. They want to gather data on the network. They want to map our network. They want to footprint our network so they can see what targets to go after. They're also looking for personal information, private information such as credit card information, social security numbers, names and addresses, and so forth. They're looking for proprietary information from our company. They're also looking for sensitive information, any kind of information that we don't want out in the open. Now, how do you protect data from being sniffed and analyzed? Well, encryption is the best way. Encryption is the best method to protect against traffic analysis and sniffing. Now, we know that we can encrypt both the header of a packet and the data portion of a packet. Both those can be encrypted as we need them. Now, header data is not normally encrypted unless we're going across an untrusted network, such as a VPN. Normally what will happen is this header data, a packet header, will be encapsulated inside of another kind of packet, a transport packet that goes across the internet or an untrusted network, using a technology such as IPsec, for example, in tunnel mode. Now, we would want to do this so that between the two VPN points across the untrusted network like the internet, the internal header data that's meant for the local area network is encrypted and it can't be decrypted. It can't be looked at. We don't normally encrypt header data over a local network, and we can't do that really because the various network devices and hosts need that header data in clear so that it can read and know where that data goes, how to route it, and what to do with it once it gets to its destination. So header data is not normally encrypted over a local network. This is normally called transport mode. Now, we can encrypt data to keep it from being read over both local networks and over the internet or external networks. And data is normally where we do most of our encryption. Now, we can encrypt data at the network level using various protocols or at the application level. And there's a little bit of a difference, and I'll explain what that difference is. For a network, what you're basically doing is encrypting a session between two devices, between your host and the web server, for example, or between your host and another host. You're encrypting the link itself, either the session itself just for that particular session for a particular piece of traffic, or a constant connection, link encryption. And there's various ways to do this. You can use IPsec, IP security, which we've talked about a little bit earlier, and you can use that on both LANs, local area networks, and with VPNs. It's a very versatile protocol, and it encrypts. You can configure it to encrypt just particular sessions, just particular kinds of traffic, such as FTP traffic if you like. Or you can use it to encrypt traffic only between certain hosts. So if you have a finance server that people log into, that traffic can be encrypted, whereas traffic to another server may not be encrypted. You can also use Secure Shell, and what Secure Shell or SSH is used for is to do remote administration, so that administrators can get to their boxes remotely and send usernames and passwords and do administration over a secure encrypted connection, and this is very difficult to sniff. Another form of network type encryption is Secure Sockets Layer, or SSL, and we know that normally by using HTTPS, secure web browsing. Maybe when we log into a web server, do our financial transactions over a secure web server, or send any kind of sensitive information to a web server that we want to be encrypted. So it encrypts web traffic. Authentication protocols are another form of network encryption, and what they do is they encrypt our user credentials, usernames and passwords between our hosts so that they can't be sniffed and our passwords can't be leaked to someone else. There's different kinds of authentication protocols. Some aren't that great, such as NTLM, and some are actually fairly stable, such as Kerberos.